side goes.
You twist that. That kind of locks it. Did you do that down there? Maybe. Yeah, you did. Yeah, you did that. Yeah.
Okay.
So now, turn on the measure.
You want to inputs.
Yeah.
It's reading 18.
Yeah. So now.
So the range for this guy should be falling somewhere in between 0 and 30. No.
Yeah. No, because you have this set to 30.
Yeah.
The instrument, these linear pots are going to range. The output signal is going to go from 0 to 30.
Okay. So
I
I was right.
Yeah, you're right. But I wanted you to think about why you're saying what you're saying. Yeah, if you set this to 10, then the instrument's going to range from 0 to 10.
Okay.
So it's the more voltage you apply, the better, because you're taking, say that instrument travels 30 inches,
Mm-hmm.
right? You're basically saying, for every inch that the instrument moves, you're gonna change the voltage by 1 volt. And so based on how accurately you can measure that voltage, that's how accurate your reading is gonna be.
Mm-hmm.
But now if instead of 0 to 30, you had 0 to 10, when you move that instrument 1 inch, it's only gonna change 0.3 volts,
Okay.
right?
Yeah, I think that's
Yeah.
good.
Right. Does that you
Yeah.
get the idea though? So if the resolution that you measure voltage is finite. Like maybe you can only measure voltage to 1 millivolt,
Mm-hmm.
right? But now you've cut kind of your window down over which you're measuring.
Yeah.
So like you're losing kind of resolution in your reading, which is why the higher voltage is better. So right now, we just figured out that one, the instrument's working, this cable's working,
Mm-hmm.
this power supply, we figured out that this setup is working. If this wasn't working, if I wasn't getting 18, or if I was getting some really, really small value or something, I'd be thinking, all right, something's wrong. It could be this cable. I mean, we have a lot of these cables that are kind of broken.
Mm-hmm.
So if it wasn't working, the first thing I would do is swap this cable.
Okay.
If that didn't fix it, I would plug it into another channel. If that didn't fix it, I'd plug it into another junction box.
Okay.
Right? If that didn't fix it, you could make sure that this actually has 30 volts coming out of it.
Okay.
And if all of those things don't work, then I would take another instrument and connect it to the same cable. And if that instrument works, then you've proven that the instrument on the wall is what doesn't work.
Okay.
See how you kind of rule out things. You're like, all right, well, is the cable broken? Nope, the cable's not broken. Okay, is the junction box broken? Nope, the junction box isn't broken. Is the instrument broken? Yep, the instrument's the one thing that's broken. All right, well, now we need to swap it out.
Okay.
So
I guess.
all right, so this particular instrument,
Do we want it on a separate?
yeah,
Or do we want to put it on everything else?
because this instrument is used for our control,
Mm-hmm.
this instrument is actually getting connected to the computer that controls the test.
So, okay.
So this setup and this computer we've been using, that's just for monitoring purposes.
Mm-hmm.
So really what we want to do is we want to take this cable and plug it in. Now, I think it's, yeah, so you're going to be quick to want to plug it in right here. But this is a 1315.
Okay.
Read Let me show you.
We have one out over here too. Is this the one?
So basically, you'd be plugging the instrument. We don't have a junction box, like that aluminum kind of case.
Mm-hmm.
Right, we don't have one over here, so I would bring that aluminum case,
Okay.
that junction box, and like whack it in up here. You also have to bring your power supply over here as well.
Okay, and I can probably just set it there, maybe?
Put it up there, yeah. And then the output, the BNC cable, will get connected on, like, see, this is the, so this BNC rack is connected to module 2.
Mm-hmm.
Makes sense? Alright, so you're probably not supposed to be plugging these things in and taking them out while it's powered up, but I've never really noticed an issue doing it. Alright, so this is called the 1315. And what is, this guy is called the 1540.
Okay.
So, and it tells you on the bottom of the module, it kind of tells you what this is used for. So that's 8-channel LEDT amplifier. So this is, you can connect any type of LVDT that takes AC voltage. And the number, like 1315 and then 1540, there's no like way to easily associate one with the other. But you have to, if you go to NI.com and search for like 1540, it'll tell you like, you know, associated hardware you want, you know, 13, 15, whatever, terminals.
But there's like the other options where they're not, because it sounds like you were going to switch this out for something else.
Well, what I was gonna, yeah, so for that particular linear pod, because it's DC, we have to bring over that DC power supply and the junction box to connect it over here. The other thing you could do is leave everything over there, but buy a 50-foot BNC cable to run from there and plug it into the back there. You can do that.
Okay, which I don't think we have. So.
Yeah, I mean, they make 50-foot BNC cables. It might be easier to do it that way. But all, you know, it's like, it's another thing that's kind of like up to you. Like, how do you want to organize your wires and so forth. In the past, we've done most of our control with string pots, string potentiometers, and all of our string pots are AC driven.
So you can just,
which is why this was here to begin with, because that's we just connect string pots.
So you haven't necessarily used this type of control sensor before?
I mean, we've used plenty of linear pots for all just measurement purposes, but we've never used. This instrument is nice because it has such a wide range, and it stays pretty accurate over that entire range.
Is that not really true with this string?
With the string pots, your kind of like resolution is dependent over like your range. So like if you had a 20-inch string pot, you wouldn't be able to measure thousandths of an inch.
Okay.
A rule of thumb is you can measure down to about 0.1% of the range. So if you had like a 10-inch range instrument, you get down to 0.1% of 10 inches would be like 100th. think that's 100th of an inch.
10.
Huh?
10.
Yeah, yeah.
0.01.
0.01 times 10. Right? Times the range. 0.001 times 10-inch range of the instrument would bring it to 0.01. So you would be able to measure 1/100th of an inch very accurately with that instrument.
And then beyond that,
Turns out 1/100th of an inch is not accurate enough for the testing that we're doing here.
okay.
So either you could connect like a 1-inch string pot, and that would give you, a 1,000th of an inch control. But now you have a 1-inch gauge hooked up to the top of the wall. That over the length of the test, we're going to move the top of the wall maybe 2-3 inches. So that's not a good instrument. So we want kind of a higher resolution instrument, which is what that linear part provides. So something I kind of wanted to get the screwdriver and kind of show you. You shouldn't be scared to do this. But you can open these things up.
Yeah, I've been refrained from stuff apart.
It's pretty simple. We have a connector. You can see each channel. So it told us that there were 8 channels. 1, 2, 3, 4, 5, 6, 7, 8. And all you can kind of see like this, it says like channel 1 positive, sync 1, there's like ground, there's whatever. I'm gonna go into NI and I'm gonna show you, it tells you where all these wires should go. Plugging in a string pot into this connector and it should work. And if it doesn't, it's probably the cable's busted or the string pot's busted or whatever. But so we do have string pots connected here, right? Because we're monitoring kind of the absolute movement of our wall with string pots. So let's go to one of our string pot tasks.
So, okay, we're doing string pot incline.
All right, so
I'm gonna run it.
yeah, run it. Let's see what it looks like. So now, what is 13? Is that inches, volts, strain?
It's in inches.
Yeah, in inches.
They're scaled units.
Now, scroll through. All right, so. I hit stop.
Some of these aren't connected.
Yeah. Oh, that's good. All right, so if you want to look at, this is called the connection diagram.
Okay.
So if you go here.
Well, that's against it.
Yeah. Yeah. So for this specific channel, right? Which. So we have this thing connected to SC2, module 5, channel 5, right? So it's saying if you want to connect an instrument like an LVDT to channel 5, and you just have this crazy instrument with 4 wires coming out of it, this is what if you want this to work properly, this is how you connect the wires.
Okay.
Alright, so, it's saying, so like the pink wire is connected to this, this channel right here, and that's the negative excitation. And so you come over here and it's like, pink wire is negative excitation. And then blue is positive, and then the yellow and the red are the output. Right. It's kind of like I was talking about. There's
Just input.
2 wires for input and 2 wires for output. So now you would have to look at these 4 whichever.
there's like a
Now
ground
there's
wire.
6 wires here because I didn't see any reason not to include all 6 wires, so that all 6 of these pins represented the 6 connectors here. But in actuality, all we really care about is the 4 that are shown here.
Okay.
So I'm pretty sure the way this works, you could actually open up the back of this.
Yeah, I think.
The-
Did we leave the LVD one open? We took one of them apart.
Yeah. So you would open this guy up, and you would, you see how these are all labeled A, B, C, D, E, F, G, whatever. You could see that, whatever, the pink wire, which is white, the white wire might be pin A. And this is kind of different for each instrument group.
Yeah. So I think
But it's really just AC and DC. Those are really your only 2 instrument types.
they're not all 6-pin though, are they? Because I feel like we ran
They should really only be 4.
Okay. Because I think I've seen some 4-pin ones somewhere. I don't remember.
The extension wires, the wire that goes from here to the instrument, that only has 4 wires.
Okay.
I think if it was up to me, I would have bought 6 wires, but you only ever need 4, so it's like you just have 4. But and this is kind of getting into it a little bit, but like, let's say you're hooking up 8-string pots, and at the end of the day, you hook up all 8 and one of them doesn't work, and you determine that, this connection is faulty, like this isn't working, then it's either in the connection here, where there's like a broken wire, or it's in here. Maybe the broken wire's here, and you can go back and you can fix it, and it'll work again.
Okay.
It's not like the circuit board is fried. You know what I mean? It's really just like you probably have a short or like a disconnection or something.
Okay.
So, like,
You'd never expect there to be like something in this part? Would you ever?
unless the wire looked real beat up, like, maybe someone like stepped on it or like physically cut it on accident or something. Yeah, but no, I mean,
It's good to know.
this looks good. The strain gauges, they look a little bit different, but the same thing. Go to strain gauge channel. And go to the connection diagram. So it's like, so what we have up here is, this is the blue wire. The blue wire is connected to the red post. So the wire that's, in that black box, that's attached to the red post, travels all the way through into the DAQ and is connected to, that spot right there.
Okay.
Right? And then the wire on the white post and the black post are connected from the yellow and the blue into the other 2 spots. Exactly.
Yeah, because they share the same node. I'm just trying.
Yeah.
Try not to mix it up like I did that. Okay.
So just like the white P3000 or whatever tells you kind of how to connect a quarter gauge strain gauge, this is kind of trying to do the same thing, but it's a little bit more. I mean, we've done that for you in a sense. Like, we made those boxes. All you have to know how to do is connect the blue wire to the red post, and then the 2 gray wires, it doesn't matter. Huh?
Hopefully I don't have to make any more notes.
Yeah,
But I'm
hopefully.
sure I'll,
But if not, I mean,
I can
all you
always
have to
do
do
it.
is just copy it. You
Yeah,
know, you can
take
just
it
like
apart.
take it apart and build something exactly. I mean, that's how we made. When I got here, we didn't have those, and it was like, well, we had like one or something, a couple, and it was
Yeah.
like, well, we'll just copy. So,
Okay.
all right, so.
So do we want to go ahead and hook up the controls since we're done?
Yeah,
So-
we can.
Just to get that done.
Sure.
We want it in the top.
So here's something. So obviously this is like, yeah, I think we got this backwards. Yeah. So this looks like positive and negative, but we really like flipped it. So this is negative and this is positive.
Okay.
So here we have positive and negative. This like stub thing says like ground on it. So this is negative.
Okay. So
I mean, it doesn't matter. I mean, it doesn't matter whether you plug it in like this or like this. But if these don't align, like if you were to flip this, instead of this being positive 30 volts, it's going to be negative 30
okay. I
volts.
think we saw that when we were.
So the reason I say that is because if you connect it right like this, like negative to negative, then when you plug it in here, instead of going negative to negative, I flip it. So, like, all I'm doing is, because we screwed this up, instead of the instrument reading 0 to negative 30, it's going to read 0 to 30.
Okay.
I mean,
I guess we can check that.
yeah, I mean, you'd look at the reading and you'd be like, oh, it's negative? That's kind of weird. And all you would have to do is flip this.
Okay.
You know, so like, for the time being, I'm just going to do this. But you could like run this wire over there or something.
Yes, this way.
Really sure. See if that guy. That's like, yeah, like, let's just get the other one going.
I should just bring my screwdriver from home. It's like this. My dad got it for me.
Yeah, so
It's like an old school one. You push it and it rotates. Like you just
Ah.
pump it like this, and the thing spins like a automatic.
I know this like looks like the threads don't match up, but once you like get it through, it like stripped all the paint that's like covering the threads, and actually like it gets like really easy. I mean, this thing isn't going anywhere now.
It was like I wasn't getting it anywhere.
Yeah, and then it's just something that's, and that like means it like it's like really easy to just use 2 fingers.
I'm really loving this. He's like zooming and everything.
Alright, so now,
I noticed
yeah, we need to,
we need the cable over here.
yeah.
I need to see what's happening.
Yeah, I was gonna plug this in. We plug these into batteries because if the power goes out, our whole system doesn't just shut down. We actually have like so much time to like.
It's those
shut
black
down.
boxes that
Yeah.
are sitting right, right?
So these from the front.
that way?
This is a battery, but this is also a battery,
Okay.
and that's a battery. So I believe like this is Shore Western control unit for like one box, and this is the control unit for the other box. We like to have these have their own power supply, so I would plug everything DAQ related into this power supply. That's probably how it's set up.
Okay.
So I would plug this guy into the DAQ.